I'm going to talk about LUCID, which stands for Loop for Unbiased Calibration via Inference Time Diagnosis. And what we did is introduce a framework that debiases LLM reasoning, especially LLM reasoning evaluation, using statistics and statistical methods. So the aim is to debias LLM reasoning at a low cost without retraining at inference time. That's the aim, and we achieve that. But let's start at the beginning. So LLM agents reason via chain of thought traces, and I think most of us have experienced that. But should we trust those reasoning steps, and are we actually evaluating them enough, or are we just evaluating the final task completion? That is a question that I ask myself. If we want to trust them, we need to have some kind of proper rating system. And the gold labels would, of course, always be experts, but experts are very, very costly for full annotation. So we were thinking of how to actually reduce the costs. And maybe that could involve cheaper LLMs that could help us with rating those reasoning steps, whether they're good, they're bad, or just somewhere in between. So our question is, how could we diagnose the bias from like a few expert labels so that we don't need full annotation? And how could we use that to actually improve the LLM reasoning or the rating of the LLM reasoning steps? Exactly. So for that, we actually used datasets that have been used to train process reward models that are labeled. There are datasets such as the PRM 800K dataset, which has a lot of problems that are not only labeled by their task completion, but also how good the reasoning steps were and whether the reasoning steps were actually right or wrong. So that's what we started with. And we kind of artificially limited ourselves to only use 1,000 expert labels because that's what we thought could be somewhat of a realistic scenario that whatever an organization or research group or whoever wants to evaluate their LLM's reasoning could manually do. But it was great to have the PRM 800K dataset, of course, for evaluation. And yeah, that is what we started with to evaluate our framework on. As a background information, we use DSL, Design-Based Supervised Learning, which is a statistical method. Our essentially detection mechanism for bias in a statistical way. Yeah, we crossfit a model, like an honest forest model, that predicts the true label from the bias prediction and the features. And then we build a pseudo outcome. So the model's prediction on every item plus the residual on the labeled items. And DSL gives us two things that we'll use, like a debiased estimate and a biased diagnosis, so that we can then have per feature gaps between biased and corrected rates. And it's like basically a pseudo model that is on top of what the LM actually predicted, that gives the corrected version, and that helps us calculate the gap.
What are the inputs and the outputs here?
Right. So whether the step is correct or incorrect was or not of highest importance for us. It was more about whether the rating of the step done by the LLM was actually right or wrong. So we had those gold standard expert labels that we assume are right. And then we had the cheaper LLM, which in our case was GPT in most cases. But then I'll come to that later. We also compared that to another model just for evaluation purposes. And we had that rating. And we tried to see whether the rating of GPT 5.4 mini was actually correct or wrong. It was not about whether the step yielded to a correct implementation, correct task completion.
So the idea is we have all these reasoning steps, and we can generate those on the fly with a new model. And we want to get if we could rate those accurately, we could then choose which reasoning outcome is the best based on the quality of the intermediary steps. But we don't have the ability to apply human ground truth, human labels to that at will, because that's so expensive. So the idea is we'll generate all those reasoning steps on the fly. We'll generate a bunch of ratings for those reasoning steps, and then we'll adjust those ratings based on the the DSL procedure to debias the LLM judgments of those reasoning steps.
That's what we did. So we come to our contribution now, which exactly is what you just described. So the agent in our case, GBD 5.4 Mini rates the step or many steps. And then we analyze with DSL as told, or we diagnose whether there is bias or not. If there is bias, then we can feed that statement or just our bias diagnosis back to the agent so that the agent can re-rate itself, and then we'll test if that new rating is again biased or not. And this is the LUCID loop that yielded a very good result in that sense that even after one loop, it oftentimes improved itself a lot. And yeah, it was very cheap in that sense. So yeah, I guess that's kind of our success. And we did this with no weight updates, no fine tuning, no extra labels. Kind of that's what makes it, I guess, a bit special.
That's awesome. I'm just trying to think of failure modes now. So the intuition here is we're leveraging the human labels at inference time in a principled way. I think that's the intuition about why it's working. But it would be expected to fail if the reasoning task where the human labels were applied is very different than the reasoning task analyzed at inference time. I'm just curious to hear your thoughts. What are other potential limitations as well as areas where you think this would really work well?
Yeah, no, absolutely. You're right that if the labels are not correlated enough with the task that the agent is currently rating in that sense, then of course it loses its value. And also in general, if the rating so where this works well is always when there is a high systematic structured bias. So if we can diagnose a structured bias in the labels, then we can oftentimes confidently say that that structured bias might also exist in future ratings that the agent does. So that's where this works good. But of course, if there is some kind of randomized bias, like that's not bias, that's noise. But if there is noise, essentially, then it makes the life of Lucid very tough for sure.
In other words, and I think you'll get to this in the results, we can be wrong for two reasons. Either the model is systematically biased or it's essentially incompetent in each reasoning step. And this lucid procedure works well in the case where the bias is systematic. However, it struggles when the model is simply incompetent in each of its steps.
Yeah, exactly. That's also kind of our headline statement that we make at the end, that we can correct bias, but we can't correct incompetence. So I guess that's intuitive that we cannot correct incompetence at inference time or test time without any kind of additional layer that adds complexity to the problem. Like it can't be corrected by just giving some feedback. It can be compared very nicely with humans. You can, like, if a human has a skill but just accidentally thought that there is some bias or had some bias in his head, then you can of course just help him with one statement correcting the bias. But if the person needs to learn the whole skill, I guess that's a different story. That's how we treat that as well. And as I said, so our key insight was actually that there is structured bias in rating of LLMs, and we could find that. For example, that when there are very long horizon tasks, then LLMs tend to, for example, rate rather negatively than positively. So that's a very intuitive and very, very simple example, but such biases could be, of course, corrected very easily. But we also have the issue that if there is a lot of, for example, underrating, then we tend to overshoot in other categories because of our rather simple prompt feedback. So that's kind of a downside of our framework, if you want, and that we could further work on, so that we try to not make things worse if they were actually better before our correction, even though the overall correction is still positive in that sense. yeah, we want to, of course, succeed in all categories if you want. Yeah, that's our aim. Closer to zero is actually the best. So that's why all like when the rating bias was very negative originally, we could correct it and bring it closer to zero. But if the original bias was kind of, or no, this is also better, but this one is making it worse because like the original bias was closer to zero, but then we overcorrected it and made it overshoot. Exactly. But what we also did was to check whether the calibration, the debiasing, actually mattered in the downstream task. So we ranked candidate trajectories by their average step score and picked the best. And with raw GB5 mini scores, the top one selection is at 15.2%, but with the DSL calibrated scores, it is 28.9, which is kind of an improvement of 13.7 points. And it actually beats the expert gold standard curve at N, like up to 5, and then it kind of just closes the gap. But up to 5 is actually the tougher task, so it is actually quite a good result in our eyes. And yeah, it's just cool that like a 30-cent statistical correction of a cheap rater can outperform like this very, very costly expert annotation for this specific task, which was on the PRM 800K dataset on math problems. So yeah, this was just out of curiosity also whether we could actually improve downstream tasks with the calibration. That's what we checked. I think this one is very interesting for us as well. So we tested also against another model like GLM 5.2, which is an open source model, which kind of is regarded as a very good open source model. And so what we wanted to check is whether these findings hold across different models, because until this point, we only saw results with GPT 5.4 mini, and we could actually see similar results with GLM 5.2 as well. And then we also tested it against other data set and also other domains in that sense, whether and wanted to just look whether it actually improves performance on other data sets as well. And we could see that like with the same domain, but other data set, which is process bench, which also has math problems, we still yield an improvement of 5.2%. And like, yeah, if there is a huge bias actually, which was the case in entailment bank, which is a science data set, science problem data set, we could have a huge gap reduction. It is just showing that it can yield very good improvements at times when there is a high structural bias or initially in the ratings. And then Mind2Web are web agent traces. So the rater was very, very conservative. So we actually could come down from a 89% calibration gap down to 2.6 to a 2.6 point calibration gap, which was kind of interesting, but that only works if there is a high initial bias. So yeah, now we actually come kind of to the question that you already posed, like is LUCID fixing inability or biasness, essentially, right? So LUCID can only fix biased models, but not incompetent models that are not able to solve a specific task, by essentially fixing calibration of just systematic biases, systematic errors. And this can lead to extreme benefits at times when there is extreme systematic bias, which we showed in the Mind2Web dataset, but also there sometimes is not a huge systematic bias. And then, there can be not a huge gain, which potentially like the model GPT 5.4 mini was just not able to rate as good as needed. And if it is already calibrated, it can mess up things, which we saw in the Dumble plot, where if it was close to zero, it tended to actually overcorrect things, which of course is not the best, which we need to address and we will address in in our future work. So what are the takeaways of this LUCID paper that we presented? For one, LLM rating bias is structured, and hence it is diagnosable and actionable. And we can fix it with just one round of statistical feedback, which is super cheap and doesn't require any costly hardware or long retraining and stuff. And also that DSL is a strong diagnostic tool to actually detect bias if you have expert labels, at least for similar reasoning steps in that sense. But I think the most important takeaway is there is a difference between calibration and discrimination, or bias and incompetence, or bias and inability, and you need to know which one you need to fix. And we can only fix the former one, but not the latter one, because that needs retraining.
Thank you. A couple questions. One thought is, you could imagine scaling this up by having, for a new task, a more expensive LLM, potentially annotating up some of these reasoning traces on the fly and then applying a DSL-like procedure to cheaper models. What are your thoughts on ways of generalizing this? Do you think we need a human in the loop? Can we generalize out the human? What are some of your thoughts there on, making it so that we can scale this up a lot bigger than currently across multiple tasks where we don't already have those expensive reasoning traces?
Yeah, no, absolutely. I mean, essentially, it is just the same concept. We could just have costlier expert models instead of expert humans that could help our smaller models to improve their ratings or just diagnose the bias. And that's definitely a very, very viable option. We have not tried that yet, but that's actually a good idea to try that, because we wanted to, like in the first paper, we wanted to make sure we work with real expert gold labels, because otherwise it can be, one could maybe fall into the trap of thinking we're improving because we're living in the whole LLM world in that sense. But you're absolutely right. Now that we've showed that there is that bias, we've shown that the framework kind of works with human expert labels. I'm pretty sure we could actually use costlier LLMs to diagnose the bias first with the help of, for example, DSL, and then try to improve it down to the cheaper LLMs and improve their ratings for sure. Potentially we can actually, expert LLMs are still cheaper than expert humans. One could potentially think of rating more or rating specifically in clusters and similar things, so that we could always have the perfect DSL diagnosis for our specific task at hand in that sense. Yeah.
Another thought would be, if it's hard for the model to really get a rating or to think through that scale, using pairwise comparisons can be a method to deploy in that context where there is no clear intrinsic scale. We can use these pairwise. This reasoning trace is better than that reasoning trace outcomes in order to try to calibrate the model further.
Yeah, no, absolutely. I was surprised to find such amount of structured bias in some ratings, which of course one assumes that there is bias, but it was a bit surprising to see that much. But also, which is even cooler to see, is that we can correct it in such a cheap and easy way. So that's a win for us, because there are so low-hanging fruits of improving these ratings, which makes it very cool.